All right, hello everybody. This is our last unit for the final exam. It's unit 6, which is dealing with triangle relationships. All right, so let's get into it. So 113, find AD. So if we want to figure out what AD is, right? AD is this chunk right here. Well, big thing on this one is since we are dealing with kind of our triangle relationships, well, since we know these two angles are the same, we know that's a right angle. That means this and this should be also be the exact same also. And this side and that side should probably be the same. But I'm going to set those two equations, that 13x minus 4 equal to 8x plus 11. And then we're going to solve for x. So subtract 8x. And I'm going to add 4 at the same time. And we're left with 5x is equal to 15. Then, last step, if we want x by itself, is to divide by 5 to get x equals 3, right? However, we're not done yet because we want to find what AD is. Well, AD is that 13x minus 4, so I'm going to take AD will be equal to 13x minus 4. So I'm going to take what x was equal to and replace the x in that equation. So 13 times 3 is 39, and 39 minus 4 is 35. So AD is 35. All right, 114. Find the measure of angle FGH. So FGH, as we look at it, right, FGH. FGH is that full angle there. But in order, if we want to figure out what that full angle is, right, I got to know what x is first. So in this one, kind of same boat, since we have that right angle, these two sides are congruent. That means this angle and this angle should be the same also. So we're going to set 5x minus 37 equal to 2x plus 20. Right, if you set it as 2x plus 20 equals 5x minus 37, it's fine, right? How we set it equal to doesn't matter because you should still get the same answer. All right, then from here, we're solving for x. So I'm going to subtract 2x over, and I'm going to add 37 over. And we're left with 3x equals 57. And to get x by itself, I divide by 3. And we're left with x equals 19. Well, now that I know what x is, right, I'm going to take that x and plug it into one of the two equations, right? I don't care which one. I'm just going to do it in one because, I mean, whatever answer I get for here should be the same answer I get for the other one too. So I'm going to plug it into that 2x plus 20, right? I'm replacing that x with 19, and I'm going to solve. 2 times 19 is 38, plus 20 is 58 degrees. So this angle here is 58 degrees, which means this angle here should also be 58 degrees, right? If you want to check, just take x and plug it in. Do 5 times 19 minus 37. You should get 58 also. Then, if I want to know what that full angle is, right, I have to add the two together. 58 times 2, or 58 plus 58, is 116 degrees. So this would be my final answer now. All right, 115, match the following word to the correct picture. So, perpendicular bisector. The perpendicular bisector is going to be this first one here, right? That is where my bisector will, it is a perpendicular bisector. So my bisector is going to make a right angle and cut this bottom line into two congruent parts, right? Next we have is median. The median goes from the an angle, goes down to the bottom line, and should split this bottom line into two congruent parts. An angle bisector is this one. The angle bisector is when that line cuts this angle into two congruent parts. And altitude, which is this last one, right? It is basically a straight line down from the corner, making a right angle there, right? We're not cutting that bottom part in half, but that's what it would be. All right, 116. Match the following word to the correct picture. So first one we have is circumcenter. Circumcenter is going to be this top one, right? Big thing how we know is that these lines right here, right? All these lines that go from the angle to our center point are all congruent, right? Those should all be congruent there. In center, this is the in center. So the in center goes from our central point straight out, making a right angle, and all these lines should be congruent there. Centroid will be this one, right? The centroid is where we have that kind of that dot, our point, our center point in the middle of the circle. And the orthocenter is this last one. All right, let's keep going. Once again, if you need questions, concerns, anything, make sure you ask your teacher for more clarifications, right? You can pause this video whenever you see fit. Give them some time to practice, take some time to practice. All right, so 117. If G is the circumcenter of triangle ABC, AG AG is 6x plus 1, GC is 9x minus 11, and BC equals 38. Find GF. So we want to find what GF is, which I'm going to put in orange here. So first thing, I'm just going to label my specific things. So AG here is 6x plus 1. GC, so from here to here, oops, sorry, don't pick orange. From here to here is 9x minus 11. And BC, sorry, let me erase this for a second. That's 9x minus 11. And BC, this whole length here is 38. So find GF. All right, so we got everything labeled. So one thing, first thing I'm going to do is I'm going to deal with the side. So with circumcenters, this chunk should be congruent to that because that line is cutting that segment in half. So this will be 19 here. This is 19, right? If the full distance is 836, we cut it in half, you get 19. Well, now, if I want to figure out what GF is, I need to know what X is because this chunk, this line, and this line from G to B, those three lines are all going to be the same. So I'm going to set that 9x minus 11 equal to 6x plus 1. And then same boat, I'm going to go through and solve for x. So I'm going to subtract 6x. And I'm going to add 11 right now. So we're left with 3x equals 12. And then we divide by 3 to get x equals 4. Okay, so that's the first thing I did. I found what x. Now I want to know what that side length GC is, AG, BG, right? Because they're all going to be the same. So I'm going to we'll do 9 times 4 minus 11, which 9 times 4 is 36. Minus 11 tells me that that side length is 25. So this is 25, this would be 25, this is 25. Well, now if I want to find what GF is, well, remember when we were dealing with circumference, we have a right angle there. We're dealing with perpendicular bisectors. So I can use Pythagorean theorem now to figure out, because I got two of the sides of my triangle here, right? I just need to find that missing side. So I'm going to do, we'll say a squared plus 19 squared equals 25 squared. So we're left with a squared plus 361 equals 625. We would subtract that 361 over, and we're left with a squared is equal to 264. And to get a by itself, we take the square root. To get a is equal to roughly 16.2. So this 16.2 is what that length of GF is. All right, let's keep going. 118. If V is the in-center of triangle PQR, QT is equal to 5, VU equals 7, and PV equals 29. Find each measure. All right, so first thing, let's label it. So QT, so this little chunk here is 5. VU, so this chunk here is 7. And PV, maybe I'll change colors, 7. And PV, this line is 29. Find each measure. So I want to figure out what SV is. Well, first thing, I can figure out a lot of this because this line VU to TV to SV, all three of them should be the exact same length. So SV is 7, TV is 7. Okay? Well, similarly, if I want to find QS, well, QS is this chunk right here. Well, it should be the same as that chunk right there. So it should be 5. Next, we want to find QV. Well, QV, sorry about that. QV is this pink line right here. So if I want to find that one, once again, well, I have a right angle here. I got two of my sides. I'm going to do 5 squared plus 7 squared equals C squared and solve for what C is. So we're left with 25 plus 49 equals C squared. 25 plus 49 is 74. And we take the square root of that to get that C equals 8.6. So QV is 8.6. And lastly, we want to find what PS is. Well, PS is this line right here. Well, once again, I have a right triangle. I know two of the sides as 7 and 29. So I'm going to say it's 7 squared plus B squared equals 29 squared, right? You could have said A squared plus 29 squared equals, A squared plus 7 squared equals 29, but it's okay. It doesn't matter which way we wrote that, right? A and B are fine for both this knowing the sides, but we're going to go through and solve it again, right? 49 plus B squared is equal to 29 squared is 841. I subtract 49, and I'm left with B squared is equal to 28, or sorry, not 28. B squared is equal to 792. And we take the square root of that to get B equals 28.1, roughly. So PS is 28.1. All right, so let's keep going. 119. If P is the centroid of triangle JKL, PN equals 5, LM equals 33, and KP equals 16, and NL equals 13. Find each measure. Okay, so let's label my sides. So PN, this is 5. LM, so the full length of this line here is 33. KP, so from there to there is 16. And NL, this side length here, is 13. So if we want to find our missing sides, we can do that, right? So PN. So on this one with centroids, we have kind of one thing we can do. So this PM chunk here is the smaller portion of that line. So if I want to figure out what the length of that is, I take 1/3 of 33, which would give me 11, right? So if this is 11, well, this line from L to P has to be 22 then, right? 11 plus 22 should give me 33. All right, let's keep going. Same thing with this line from P to O, right? Well, if I know from K to P is 16, well, I know whatever it's got to be, that's 2/3 of it, right? So if I want to figure out that chunk, right, kind of same idea. It's going to be 8, because 8 would be 1/3 of 24. 16 is 2/3 of 24. JP. So same boat once again, right? I know what part of my line's 5, the other half, JP, is going to be 10. JN, right? So the full length of that line will be 15. And lastly, KL. Well, if I know this chunk's 13, where my green is, this chunk here is also going to be 13. So KL will be 26. All right. 120. Classify each triangle center below. So this first one is a orthocenter. The second one is an incenter. And the last one is a circumcenter. All right. So let's keep going. We have a few more problems to do. So 121. If RT is the perpendicular bisector of QS, find X, right? Well, if we have a perpendicular bisector, if those two lines are the same, these two sides should also be the same too. So we're going to say 7x minus 22 equals 4x plus 5. And we're going to solve for what x is, right? Again. So we'll subtract 4x, and I'm going to add 22 to the other side. So we're left with 3x is equal to 27. We divide by 3 to get x is equal to 9, right? This one, if it only asks us to solve for x, so we're done here. But if it did ask us to find what RQ is, or RS, or anything else, we could figure it out, right? From here. All right. 122, find the measure of angle XWZ. So XWZ is just this chunk here. So when I want to go to solve for what that angle is, I need to plug it into there. But big thing on this one, right? First, in order to solve it, I got to set these two equations equal to each other. And then solve for x. So I'm going to subtract 3x over. And I'm going to add 32 over. And I'm left with 5x is equal to 35. And to get x by itself, we divide by 5. X equals 7. Well, now, right, I want to know what this green angle is, so I'm going to do 8 times 7 minus 32. 8 times 7 is 56. Minus 32 gives me that this angle is 24 degrees. And that would be my answer in this one. All right, let's keep going. So graph triangle CDE with C. All right, so let's plot them as I talk through it. C at negative 2, 7. C. D is at 8, 7. D. And E is at 2, negative 5, 1. E. All right, let's connect my dots. All right. Then order the measures from least to greatest. Okay, so in this one, if we want to order the measures from least to greatest, I need to know at least my side lengths or my angle lengths, preferably side lengths in this one since we're ordering angles. Well, I can figure out a few of my side lengths pretty easily, right? CD, since it is along a flat line, I just need to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this side length is 10. Okay, now if I want to figure out what my side length for CE is, I'm going to draw my triangle out, count those two sides, and then do Pythagorean theorem to figure out. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This side's 12, and this is 1, 2, 3, 4. 4. So I'm going to do 4 squared plus 12 squared equals C squared, right? That's line CE is my C squared. So we're left with 16 plus 144 equals C squared. 144 plus 16 is 160. And then we take the square root of that to get C is roughly 12.6. So this side length is 12.6. Well, we're going to do the same idea for this side DE, right? I'm going to draw my triangle out. And I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This side's 12. This side is 1, 2, 3, 4, 5, 6. So same boat. I'm going to do 6 squared plus 12 squared equals c squared. We have 36 plus 144 equals c squared. 36 plus 144 is 180. We take that square root, and we're left with c is equal to 13.4 roughly. So this side is 13.4. So now if I want to order my sides from least to greatest, remember, I go from my smallest side directly across. That is my smallest angle. So angle E is the smallest one. I go from my middle side, the middle length, second smallest, directly across. That is the middle angle. And largest side, go directly across. That is my largest angle. So angle E is the smallest, angle D is the middle, and angle C would be my greatest angle. All right, let's keep going. 124. Which of the following could represent the side lengths of a triangle? So if we want to see if this is a triangle or not, right, my general rule was my two shortest sides, so A and B, have to be greater than C. So if I want to figure out what is a triangle or not, this statement has to be true. So it doesn't matter the order, right? So my two smallest sides, so like for this first one, right, I'm going to do 11 plus 17 must be greater than 19. If that's a true statement, then we have a triangle at least. So 11 plus 17 is 28. Is 28 greater than 19? Yes, that's true. So this is a good one. Right now, when I do the second one, right, I have 23, 28, 52. So I'm going to do 23 plus 28 should be greater than 52. 23 plus 28 is 51. Is 51 greater than 52? No, that's not a true statement. So that one's wrong, right? Next, I'm going to do 9 plus 25 has to be greater than 34. Well, 9 plus 25 is 34. Is 34 greater than 34? Once again, no, that's not true. That's wrong. And for that last one, I'm going to do 13 plus 14 needs to be greater than 22. 13 plus 14 is 27. Is 27 greater than 22? Check, that's correct. So A and D are the only two that that could at least represent a triangle in this phase, right? B and C, those two, those side lengths will not make a triangle. All right, 125. The lengths of two sides of a triangle are 36 meters and 48 meters. What is the range of possible meters, length in meters, for the third side X to be? So I'm going to say X. If we want the range, right, X has to be bigger than something but smaller than something else. Well, to get this side, what X has to be greater than, I'm going to take the two numbers that are given us, the two side lengths, and I'm going to subtract them. So 48 minus 36 tells me we have to be larger than 12 meters, right? We can't be 12. We have to be larger. And to get my largest side, I take those two numbers again and add them instead. So 48 plus 36 is 84 meters. So the third side for this triangle can be anywhere between 12 and 84, right? It can't be 12, it can't be 84, but it can be anywhere between. So I could do 12.1, and that would make me a triangle. I could do 40, that's going to make me a triangle. But if I did like 85, not going to make a triangle, right? Because that's outside this range here. If I did 10, outside that range, not going to make a triangle, right? So anywhere between those two numbers will make a triangle here. All right, to 126. Give the angle measures in order from least to greatest. Once again, we take the smallest side, go directly across. That is my smallest angle. So angle C, middle side, next smallest, directly across. Angle B, largest side, directly across. That's my largest angle, angle D. All right, 127. Give the side lengths in order from least to greatest. Okay, so this time they give us angles. So first thing we got to do, let's figure out what this angle is, right? We have 57 degrees here. This is 64 degrees here. So I'm going to do 180 minus 64 minus 57, which leaves me with this angle being 59 degrees. So it's similar to how we dealt with the sides, right? My smallest angle directly across, that side there is my smallest side. So KM is the smallest, right? Second smallest angle, directly across. This whole side, LM. Largest angle, directly across. Largest side, LK. Right, if you say KL or ML or MK, that would be fine too. I just wrote it like that. But that's my order from least to greatest. All right, 128. Determine whether the side lengths could form a triangle. Prove your answer with an inequality. Right, once again, if we want to prove they are a triangle or not, they need to make this this statement true. So I'm going to do my two short sides. 2 plus 5 must be greater than 10. Is 7 greater than 10? Nope, that's not true. This one's a no. All right, 18 plus 25 has to be greater than 37. Well, 18 plus 25 is 43. Is 43 bigger than 37? Yes, this one's good. Same thing. Add my two smallest sides together. 15 plus 37 has to be greater than 50. 15 plus 37 is 52. That is greater than 50. So yes, this one's good also. And the last one I'm going to do 7 plus 24 has to be greater than 31. Is 31 greater than 31? Right? No, that's not a true statement. So this one's a no. All right. And the last problem, 129. Given the measures of the two sides, Given the measures of the two sides of a triangle, find the range of values for the third side. So if I want to find the range of values, once again, I'm going to add and subtract. So for this first one, I'm going to subtract the 2. So the smallest number I can be at is 5, and the largest number I can be at is 15. So my range is anywhere between 5 and 15. Right? Can't be 5, can't be 15, but anywhere between can be. All right. B. We're going to do 37 minus 25, which gives me 12, and 37 plus 25, which gives me 62. So we're going to be anywhere between 12 and 62. C. We're going to do 37 minus 15, which gives me 22, and 37 plus 15, which gives me 52. So we're anywhere between 22 and 52. All right, and lastly, D. So same thing, we're going to subtract the 2, and we're going to add the 2 to get 55. So in this one, we're anywhere between 7 and 55. All right, so that is all for this final exam review. Right, no more after that. The last page was just a coloring page. So that's all for these final exam reviews for semester 1 final. Right, remember, if you have questions, make sure you ask your teacher during class before the final to clarify anything you're not sure about. But that is all for these. Thanks for watching.